Greetings, detectives. Mrs. McKay, and this is our first clue in our second case, which is the case of the pet sitter solutions. And this lesson should be fairly short. We are going to just review and make sure that everyone understands that there are two different forms that we can see linear equations in. Remember, a linear equation is the equation of a line. And the one way that we have been familiar with is the slope-intercept form. And that is y equals mx plus b. And if you remember, the m stands for the slope of the line, and the b stands for the y-intercept. And those are usually constants. Sometimes the slope is a fraction like 1/2 or 2/3. Sometimes it's just an integer like the number 2 or 3, but we can write it as a fraction, 3/1. And the b is also a constant. But the y and the x remain variables, and what we do is the y and the x change depending on the point on the line. So the x and the y represent the coordinate points, or each point on the line. So if 2, 3 is a point on the line, then if we put 2 and 3 into the equation, it would be a true statement. So that's slope-intercept form, and we've done some work with graphing those lines using slope-intercept form. And today we're going to talk about another form, and that's the standard form. And the standard form is written as ax plus by equals c. And the a, the b, and the c represent constants, and so it's really the exact same line that we have in y-intercept form, or the slope-intercept form, but it's just rearranged a little bit differently. Notice that in the slope-intercept form, we have the y all by itself, it's isolated, equals mx, which the m stands for the slope, but the x is on the other side of the equal sign, plus a constant. In the standard form, we have the x and the y on one side of the equal sign, and then the constant on the other side. So we're going to see how these all look as we do some problems. So the first thing I'd like you to do is I'd like you to go ahead and write our learning target clue, and that is I can write a linear equation. So go ahead and write the word linear in slope-intercept form and you should be copying this onto your paper, and standard form. Now, one of the things that I want you to think about as you're looking at equations is being able to identify whether or not it's in slope-intercept form or whether it's in standard form. So let's look at a few. Let's look at y equals 3x plus 1. And let's decide whether that's in slope-intercept form or whether it's in standard form. Which do you think it is? Well, we can look at it and we can see that there's a y by itself, there's an x with a coefficient, and then there's a constant all by itself. And so this is actually in slope-intercept form. The y is by itself, the 3 represents the slope, and the 1 represents the y-intercept. Let's try another one. What about 3x plus 2y equals 4? 3x plus 2y equals 4. What do you think that is? Is that in slope-intercept form or is that in standard form? Why don't you make a guess? What you'll see is that there's a 3x, there's a 2y, and there's a 4. And notice that in our standard form, it's ax plus by equals c. So this is in standard form. And our a is the 3. Our b is the 2. And our c is the 3, or is the 4, sorry. So those are our two forms, and as long as you can recognize, if you can see the x and the y, if you can tell that one is slope-intercept and one is standard, you should be doing just fine. Now it's time to actually switch them back and forth. So let's look at these first set of problems. Change from standard form to slope-intercept form. So as you look, you'll see that we have 4 problems, and each problem is written in standard form. Let's do this first one. 5x minus 2y equals 10. So what I'm going to do is I want to put this in slope-intercept form. And slope-intercept form, I'm just going to write right here, y equals mx plus b. I'm going to get this in slope-intercept form, and I'm going to do that by isolating my y. So I see that I have a negative 2y already on this side. So I'm going to go ahead and leave it there, and I'm going to move my x over, and I'm going to subtract 5x. When I subtract 5x, I cannot subtract it from the 10. It is its own term. It's only by itself. But when I rewrite my problem, 2y equals, I want to put it in the form of y equals mx plus b. So notice that the mx comes before the b. So I'm going to actually write my negative 5x first plus 10. And the reason I do that is because I want it in this exact format, y equals mx plus b. Y equals an mx plus b. But I'm not quite done yet, and I wonder if you see what that is. Well, it's that y. That y has to be by itself, and right now, my y is not by itself. It has a coefficient. It's not isolated. It has negative 2 in front of it. So to get rid of that negative 2, I'm going to divide by negative 2 on both sides, and that means I have to divide everything on the other side by negative 2. I have to divide the negative 5x, and I have to divide the 10. So now when I do that, I end up with y, which is isolated, equals negative 5 divided by negative 2 is a positive 5 halves x plus 10 divided by negative 2 is a negative 5. And now I have just taken my line that was in standard form, 5x minus 2y equals 10, and I've converted it to slope-intercept form, which is y equals 5 halves x plus a negative 5, or you could write it minus 5. See how I did that? All I did was I just moved things around and I isolated the y. Why don't you, well, let's do one more. Let's do 3x minus 6y equals 24. Let's go ahead and do this one. So again, we have the 6y with the x, and I want to get the y by itself. So I'm going to start by moving my 3x over. And I'm just going to write it over here because I know I can't subtract it from the 24. If I had left myself some more room, I might have actually put it in front of the 24, but when I rewrite my problem, negative 6y equals, I'm going to put that negative 3x in front, just because y equals mx plus b has the x before the b, the constant. So I'm going to write negative 6y equals negative 3x plus 24. Now, I'm not done yet because I need to get my y isolated, so I'm going to divide everything by negative 6, both sides. And my negative 6 divided by negative 6 becomes 1y, which just becomes y. And now I have a negative 3x divided by a negative 6. That becomes 3/6x, and actually I could reduce that to a positive 1/2 x. And then I have 24 divided by negative 6 is a negative 4. So once again, I have just converted my standard form, 3x minus 6y equals 24, into slope-intercept form by simply moving things around and isolating my y and putting things in y equals mx plus b format. Why don't you go ahead and take a few minutes and do this next problem, cx plus 6x plus 2y equals 18, and see if you can put that in slope-intercept form. Take a minute and do that. So what did you pick? Did you choose the correct format? Did you do it like this? Here's what I would do. I would subtract 6x from both sides. Y equals negative 6x plus 18. Divide by 2 on both sides. And I have y equals negative 6 divided by 2 is a negative 3x plus 18 divided by 2 is 9. Is that what you came up with? I hope so. Why don't you go ahead and try this last one? Well, what'd you come up with? Is this how you solved it? Add 2x to both sides, and I have 7y equals 2x minus 14. Divide both sides by 7, and I have y equals 2/7 x minus 2. And that's how we solve, or that's not even how we solve, but how we convert standard form to slope-intercept form. I think we're ready to move on to going the other way. What do we do when we want to take something that's already in slope-intercept form and convert it to standard form? Well, we're going to follow the same process. This time though, we're going to move everything around so that it becomes ax plus by equals c. Notice that this time we're going to put the x and the y on one side, and we're going to put the constant on the other side. So take a look at this first problem. Y equals 2x minus 3. What I want to do is I want to get this 2x over here with the y. So I'm going to go ahead and subtract 2x from both sides, and I end up with negative 2x plus y equals negative 3. And if I compare it to my standard form, ax, my a is negative 2, plus by, my b is, there's nothing in front of that y. Oh wait, there's always an imaginary 1, so my b would be 1 in this case, equals negative 3, and that's my c. Let's do this other one. Y equals negative 4x minus 6. Again, I'm going to move my x over by adding 4 to both sides. Notice that I'm putting the 4x in front because that's the way it's written in the standard form. X is first, and I don't have to get rid of any, the coefficient because it has a place for a coefficient. That's what the a is. So 4 is the a in this particular one. 4x plus y equals -6. And that is that one. This next one is a little bit trickier. Notice that this is a 1/2 x. I'm going to rewrite it so you can see it as 1/2 x minus 4. Y equals 1/2 x minus 4. Now, when you look at our standard form, and it has an ax plus a by equals c. And here's something that's a little bit tricky about standard form. We don't really want the a to be a fraction. We want it to be a constant. So what can I do to get rid of that 1/2 in front of the x? I need that to be a constant that's not a fraction. So an integer, a 1, a 2, a 3, a -4, something other than a fraction. Well, how do we get rid of fractions normally? We normally multiply by the denominator so that we can sort of cancel out that denominator. So what if we multiplied this entire thing by 2? And that means I'm going to multiply one side by 2, and I'm going to multiply the other side by 2. Well, if I did that, if I multiplied everything by 2, I would end up with 2y equals 2 times 1/2 is a 1x, or just x. And then 2 times a -4, remembering our distributive property, is -8. Now I no longer have a fraction, and that's what I want to do. I want to get rid of that fraction. Now all I have to do is just move my x over, and I've got standard form, ax plus by. So I'm going to go ahead and subtract x from both sides, and I have -x plus 2y equals -8. And I've just converted it to standard form. Now it's your turn. How are you going to convert y equals -2/3 x plus 2? And I'm going to write it just again so you can tell what this really is. It's a fraction. Why don't you take a minute, convert that into standard form, and then we'll check it and see. So let's see how you did. The first thing I would do is I see that this is a fraction, -2/3. I want to get rid of that. And the way that I can get rid of that fraction is multiply the 2/3 by 3. If I multiply the 2/3 by 3, I'll come up with a -2x. But I can't just multiply the x by 3. I have to multiply everything by 3, everything on both sides of the equation. So I'm going to multiply the -2/3 x by 3. I'm going to write it over here just because there's not a lot of room. And I'm going to multiply this side by 3 as well. And I ended up with 3y equals 3 times a -2/3 x becomes -2x. And 3 times 2 becomes 6. Now all I have to do is move my x over, and I have 2x plus 3y equals 6. And that is how we convert slope-intercept form to standard form. So again, the key thing to remember is y equals mx plus b. Why mix it up, Bob? That's my little phrase for slope-intercept form. And then standard form, that's kind of the formal name or the formal way of having a linear equation. We always have the x plus the y equals the constant. So ax plus by equals c. And that's really all that we need to do for this learning clue. Now, the last thing that you're going to do is you're going to write yourself a summary. What was the key idea that you need to remember that will help you to be able to complete this learning target? Remember, the learning target was I can write a linear equation in slope-intercept form and standard form. So what is it that's the most important thing that you need to remember to be able to do that? You're going to write that down here at the bottom. Maybe for you, it's remembering y equals mx plus b and also remembering ax plus by equals c. Maybe it's a key idea is to get rid of fractions, multiply by the denominator. You decide what's the key idea that's going to help you to remember this, and go ahead and write it right here. All right, here is where you write your key idea. Again, you decide what is the key idea that's important for you to remember. Okay? And I'll see you in class.